Chapter review for the states of matter. In part A, it asks us to look at our vocabulary terms. Match the terms in the column with definitions in column 1. Write the letter on the correct term in the blank at the left. Number 1 tells you whether a material is a solid, liquid, or gas. That would be the state of matter. E. 2. Anything that takes up space and has mass. Takes up space and has mass is matter. It's letter J. Number 3. Thermal energy that flows from higher temperature to lower temperature. That's going to be heat down here at the bottom. M is heat. Number 3 is M. 4. Temperature at which a substance changes from a solid to a liquid. From a solid to a liquid, that would be melting. So 4 is going to be H, melting point. 5. The kinetic and potential energy of the particles of a substance. Kinetic and potential. Notice it says both of those. That's key. That's going to tell us that it's O, thermal energy. Temperature is the average kinetic energy. The total kinetic energy is going to be our thermal energy. So 5 is O because it's both of those together. 6, the temperature at which attractive forces begin to trap particles here and there and crystals begin to form. Crystals begin to form. That's going to be our freezing point. A. Number 7, the temperature where some of the liquid begins to enter the gaseous state. Liquid going to a gas, from liquid to a gas is our boiling point. 7 is going to be letter P. 8, the process by which individual particles of a liquid escape from the surface and form a gas. Now, it's similar to the boiling point, but this is a different way in which you go from a liquid to a gas. This is going to be B, evaporation, because it's happening on the surface. Notice the boiling point can be inside of the liquid, or the boiling that's happening can be inside the liquid. The evaporation that's happening is on the surface. Number 9, the process by which particles move slowly enough for their attraction to begin to bring them together to form a droplet of liquid. So the opposite of evaporation here, we're looking for condensation. G. And again, remember, a really good strategy is to cross out the ones that you've used. That way you understand what is left. E, J, M, H, A, O, P, B, and G have been used. That way I don't reuse a letter twice. I don't forget what it is that I have to complete or finish as we keep going here. Number 10, when a liquid changes to a gas. A liquid changes to the gas, what is that called? From a liquid to a gas. Liquid is changing to a gas is going to turn into a vapor, so that is going to be F, vaporization. 11, the amount of force applied per unit of area. You've got force divided by area. That's going to be our calculation for pressure. 11 is C. 12, the ability to do work or cause change. That's L, energy. 13, the term referring to pressure applied at any point to a confined fluid being transmitted unchanged throughout the fluid. If pressure is applied to a fluid, what does that do to the rest of the fluid? It takes that same pressure and applies it to the entire thing. If you've ever had a bottle of soda in front of you, and you squeeze that, the rest of it's going to feel that pressure and get harder all the way throughout because that pressure transfers. So number 13 is going to be letter K. That's Pascal's principle. That's what allows us to use hydraulics, because that pressure applied to a small area can be applied to a large area and pick up really heavy things. 14, the term referring to mass divided by volume. 14, mass divided by volume. That's going to be density for us. Density is I. 15, when an object is placed in a fluid, the object weighs less by an amount equal to the weight of the displaced fluid. 15 is N, Archimedes' principle. Since when something is dipped into a fluid, it moves that fluid out of the way. The amount of fluid that's moved out of the way tells us that that object will sink or float. That's Archimedes' principle. That's N. So the last one, we took care of vaporization. We took care of pressure. The upward force of displaced fluid caused by flotation. The only one we have left then is D, buoyant force. There's our answers for numbers 1 through 16, our vocabulary from this chapter. Now to the concept review in the back of the page. We'll fill in the blanks and write in the correct terms as they correspond to each of the sentences. Water has a high blank, which causes it to heat very slowly. When it talks about heat, it kind of gives away the answer. We're talking about a specific heat. It's the amount of energy needed to raise the temperature of something one gram of something by 1 degree Celsius, and water heats very, very slowly. Number 2, solids that are made up of particles arranged in repeating geometric patterns form a crystalline solid. Crystalline has 2 L's. 3, when the crystal structure of matter begins to collapse into a swarm of free-flowing molecules, the matter is moving from the blank state to the blank state. So if it wasn't a crystal structure, we know that it was a solid, and as those particles are beginning to move more freely, it's going to turn into a liquid. Number 4, the attractive forces between particles are strong enough to keep them together as a group, but not hold them in a fixed position. The particles make up a liquid. That's why a liquid can slosh around, move around. They're stuck together. They fit the volume of the container that they're in, but they have that free moving ability. Number 5, boiling is one form of state change called vaporization. Puddles drying up in the sun are examples of evaporation, the other form of vaporization. Evaporation. Number 7, steam changing to liquid water is an example. Steam changing to liquid water. So if steam is cooling, it's going to go in the opposite direction. Number 7 is condensation. 8, as a gas condenses to a liquid, it blanks the heat that was required to vaporize it. So if it is becoming lower in its overall energy, it's going to release that. It's releasing the heat, therefore going from a higher energy state as a gas into a lower energy state as a liquid. So it's got to release that extra energy in the form of heat. Number 9, if an object's density is greater than the density of a fluid, it sinks. 10, 11, and 12, and 13, it says answer the following questions using complete sentences. Number 10, describe the time versus temperature graph for water going from room temperature to past the boiling point. The line of the graph would rise smoothly until it hits 100 degrees Celsius. The temperature then levels off at that boiling point and water changes into water vapor. So let's start with our description here. Describe the time versus temperature graph for water going from room temperature to past the boiling point. The line on the graph will rise until 100 degrees Celsius or 212 degrees Fahrenheit. The temperature levels off. And water is now boiling. Water changes to a vapor. The line on the graph will rise until 100 degrees Celsius, 212 degrees Fahrenheit. The temperature levels off and the water changes to a vapor. Number 11, explain why a gas completely fills any container that you put it in. Well, molecules of gas have this free range of motion. They kind of fill their container. Because they've got so much energy, they kind of spread to all these areas. So molecules of gas have escaped completely from the attraction of neighboring molecules. They're not like solids or liquids where they're stuck together. They are far apart and free to move until they collide with a barrier such as the walls of the container. Explain why gas completely fills any container you put it in. Gas molecules freely move to fill the volume of their container. Number 12, describe how our bodies use evaporation to cool themselves. Well, the reason why our body sweats is so that water is going to be on the outside portion of our skin. And while that water evaporates, it actually releases thermal energy, so it takes away the heat that we have on us. Another way to say this, describe how our bodies use evaporation to cool themselves. Our bodies provide the extra heat necessary to evaporate the rest of the water. So the Slower, more cool water molecules are left behind. Our bodies then allow this to be taken away. Here's how I would write this. The faster water molecules near the surface of water droplets escape when we sweat. Other water molecules evaporate by our body heat, which then cools us down. Faster water molecules near the surface of water droplets escape when we sweat. So as soon as there's sweat building up on us, the parts of those water molecules start to evaporate. That releases energy, which cools us down as well. Then our body naturally has this way in which it heats itself up and will dry off or get the rest of that water to evaporate. When that evaporation is happening of those sweat molecules, we feel the effect of that energy being released and therefore a cooling effect. Number 13, explain why water comes squirting out of a full water bottle when you squeeze it. Well, here's an example of Pascal's principle, but it's not in a confined fluid area. Molecules throughout the water press against each other, and the pressure changes throughout the fluid. So, pressure applied to a fluid transfers throughout the fluid, causing the water to come squirting out. Right? As soon as you squeeze something, the pressure that's applied to it goes throughout the rest of the entire fluid, and if that bottle's open, it'll come flying out the top of it. Hope that helps you complete your review and prepare for your test tomorrow.